and I will be the chair of this morning session, which features 3 presentations from the broader EGI community, looking at both scientific and IT or advanced computing achievements. I'm pleased to introduce the first speaker, Nanjiang from the National Bioinformatics Institute in Sweden, a few years old member of the EGI Council and representative of that bioinformatics infrastructure. Nanjiang graduated from the Beijing University in 2003 with a bachelor degree in mechanical engineering and second degree in software engineering. After graduation, he sought for a PhD in bioinformatics at the Stockholm University, where he lives now, as I heard from him, longer than he used to live in China. And in parallel with this, he undertook different positions as visiting scholar at the Duke University and postdoctoral fellow at the Stockholm University. His contribution is extensive in various European collaborative projects focused on developing solutions for storing and utilizing large-scale sensitive human data, including the federated genome archives, the genomic data infrastructure. As I said, he's serving as the representative of NBIS in EGI, and he collaborates with us for several years on delivering web servers powered by cloud computing for the benefit of bioinformatics. So thank you and welcome. Please take the stage.
No. Yes. Hello. Good morning, everyone. So my name is Nanjiang, and thanks for the generous introduction by Georgi. So first, I would like to say thank you to the conference organizer to invite me here to present our organization, NBIS, the so-called the National Bioinformatics Infrastructure Sweden. And the topic of my today's presentation is about NBIS impact on Sweden's computational infrastructure and European bioinformatics collaborations. So NBIS is a distributed infrastructure. So we have staff located at 6 major university towns in Sweden. And today we have about 120 staff. Here is a picture I've been taken in one of our recent all-hands meetings, and the majority of our staff here, and the man to the further left is our director, Ben Pensham. Apart from that, NBIS also forms the bioinformatics platform of Salaf Lab. Probably you heard about Salaf Lab, which is one of the leading institutes in life science in Sweden, and probably also famous in Europe. And moreover, NBIS represents Sweden in ELECSI, the European infrastructure for biological information. So NBIS is so-called ELECSI Swedish node. And what do we do? The core activities of NBIS can majorly be divided into 3 categories, so-called support, infrastructure, and training. Support comprises the largest section of NBIS, and this is natural because this actually originally why NBIS is founded, to support the researchers in life science research. And NBIS provides support in a wide range of fields in life science, including genomics, genome annotation, MS proteomics and protein bioinformatics, systems biology and metabolomics, bioimaging informatics, spatial omics, integrated bioinformatics, biostatistics, data publication, verification of data, data management, and so on. And the next largest section of NBIS activity is called infrastructure. In this section, we do provide services, typically web services, and we also provide computational resources, data management, tools, and guidelines. And apart from that, we also provide training, so-called advanced training in applied bioinformatics. And our target mainly PhD students, postdocs, researchers, and they are mostly like our potential or our current users. And by doing so, we not only teach them the latest technologies and methodologies, but also in return, it actually improve or make our like support work more efficient because they also grasp knowledge. And in this slide, I'm going to highlight our activities with some numbers. In the year 2023, NBIS has committed more than 100 consultations and supported more than 200 scientific projects. And specifically, we also do a so-called weekly drop-in. As I mentioned, that NBIS is a distributed infrastructure. So we have staff at different universities. And by this weekly drop-in, we meet the researchers face-to-face on site so they can come by and ask any questions they want. And by doing so, like we have strengthened our connection with the local universities. And for the training, we have accomplished 20 national courses and 5 international courses. And in total, we have educated more than 600 students. As I mentioned, many of them like at above the PhD level. And for computer and storage, we have supported more than 700 research groups and installed more than 1,000 softwares and 50 databases. And also we have like replied more than 5,000 support tickets. It has to be mentioned that the computer storage, their work is in close collaboration with the Swedish Supercomputing Institute, so-called NICE, and previously it's called SNCC. And this work has also been carried out in connection with the data center, which is another platform in Salaf Lab. And as I mentioned, the support forms the largest section in NBIS. And because the technology evolves and our organization also like changed accordingly. And currently, the support section has been further divided into 5 different groups to fit need. And they are health and clinical research, evolution and biodiversity, microbiology, immunology, structural biology, cell and molecular biology, as well as bioimage informatics. And each of the team are led by 1 or 2 senior experts from NBIS. So for the bioimage informatics, also called BEEF, they provide state-of-the-art analysis using computer vision, machine learning, and bioinformatics. And they also provide support and training for the image data analysis. Here, I showed 2 examples out of their work. And the first one, they use like a dynamic imaging to visualize the checking of red blood cells in zebrafish. And in the second one, which is called TIS-UU Maps, it's a web browser-like tools or can be installed locally as well. And this method enables visualization of millions of data points overlaying on the slide, on the tissue. And the users can also like modify it in a very quick way. And we also have a dedicated group, so-called systems development team, and they carry out various of the development tasks, including the collaborations with some European organizations. So for example, one of the tasks is called hosting of national resources, such as SWIGEN. And SysDev teams also do the development of software, workflows, and services. Some of the examples are the Human Protein Atlas, and also the TopCons, which we collaborated with the EGI, and also the Metabolic Atlas, which provide like a user-friendly interface for metabolomics. And NBIS SysDev team also works on the infrastructure development and maintenance. And many of the tasks you probably have seen, like including the Europe Genome Phenome Archive, European Genomic Data Infrastructure, the Big Picture, and UCAM. And all these work are carried out in collaboration with other European countries. And in addition, NBIS also works on, the system team works on like maintaining community important softwares. And this software has been developed, but the research group, they probably don't have the funding for that. Then we take over so that the software can keep on serving to the community. And one example is called NBIS, which is one of the most widely used tools for like generating phylogenetic trees. Yes, the ADA Data Hub. ADA Data Hub is another group from NBIS with a focus on the research and the clinical innovations in data-driven precision health. And their task is like to provide computer services for sensitive person data. And this is probably the only group they actually have the hardware, as shown in the picture to the top. And this one, they provide a system so-called SDS2, the sensitive desktop service, which is users who want to use the sensitive data, they can open, turn on a virtual machine as a desktop and do the analysis there. And in addition, they also provide data sharing services for citable data sets. For example, the big picture I have shown in the previous slides. And to be mentioned that the data they provided has been used by many countries worldwide, including Asia, South America, and North America. Another team from NBIS is called Computational Resource, short named SCORE. And I previously mentioned that the computer and storage section from NBIS, they are in close collaboration with the Swedish National Supercomputing Center called NICE. And this is because NBIS, in general, we don't provide hardware. And actually, it's true like in almost any research groups in Sweden. We centralized all the computer resources in one organization. And then when a research group wants to use supercomputers, they apply for a project from this institute. And the team SCORE, it provides a bridge between NBIS and NICE. So we have people with close connection with the supercomputing center. And by doing so, like we not only enabled like our staff, because our staff do lots of genetic analysis and need the use of supercomputing, but also the users we support, these life science researchers in Sweden. Then we have men in the middle, like to enable, to make it easier for us and for the users to make use of the supercomputing system. And this team also provide like a digital research environment using Conda and using Singularity things so that it makes easier for the researchers to run their softwares in the supercomputing system. And they actually have a number of application experts which directly help the users with software and the resource. And all the aforementioned activities, except for some of the infrastructure works that have been done by the SysDev, they are mostly targeting nationally within Sweden. But as I mentioned, NBIS is a Swedish node in LXC. Therefore, we also carry out like lots of collaborative works across Europe. And here are some examples. In human data, we have been working on federated EGA, the 1+MG initiative, the GDI genomic data infrastructure, the EHDS2 pilot, the European Health Data Space pilot, which define the regulations and the guidelines. And also the big picture, the project which works on the pathology slides, the digital slides, and also the UCAM for the cancer imaging. And in data management, NBIS has been involved in the LXC Converge, which is a project aims to standardize the data management and the guidelines. And NBIS has also been involved in the biodiversity project called the BGE, the Biodiversity Genome Europe. And in training, NBIS plays like a quite active role in training. And one of the projects we have been involved in is called the FINET, which aims to do the advanced training in tools method for so-called plant related science. And for the integrated bioinformatics, NBIS is involved in the EGI2024, the European Joint Program for Rare Diseases. So many projects we have been actively play a role there. One of the projects we have spent quite much effort and contributed significantly is called Federated EGI. And EGI stands for European Genome Phenome Archive. It is a resource for permanent archiving and sharing of personal identifiable human genetic and phenotypic data. And it follows the FAIR principle, that is findable, accessible, iterable, and reusable. And this project EGI was launched already in 2008 at EBI and was further developed together with CRG from Spain since 2012. So that when you have, not sure if I can make a speed pointer. Yeah, so you have centralized like the data set with metadata, and when the user want to have access to a data of interest, they can search in the central website and find it and then download data of interest. But however, when it comes to sensitive data, it becomes tricky because by law, it makes that sensitive data cannot be freely or it's very hard to move from one country to another. So how do we solve it? Then people come up with an idea about federation. In the frame of federation, the sensitive data, it will be stored locally at the country where it is produced. It will not move. Then the metadata, which describes the raw data, it will be still stored centrally and shared internationally, so the user can still find it. Then we create a system called Federated EGI to stitch them together. And when a user wants to have access to data, they will across the system and apply for the access through so-called data access committee. And it will be decided based on case-by-case basis. When the law, there will be like some complicated law processes. But so far, like it makes it possible for the users even outside of the countries where data is located to access the data when it's required. And NBIS is one of the leaders and the earliest developers in this federated EGI. Another project NBIS has played an important role is called the genomic data infrastructure, which is ongoing. And this project, the aim is to implement the infrastructure for the 1+million genome initiative that will enable secure access to genomic and clinical data. It has been mentioned that NBIS is one of the first members of 1+MG since 2018. And this project, there are about 20 European countries and in total 54 partners being involved. So it's a pan-European project. And in total, there are 14 million euros over 4 years. And NBIS, together with ELIXI Finland, leads the work to deliver, deploy, operate, and maintain the infrastructure and services defined by the 1+MG proof of concept. But however, even today, exactly how data should be accessed and should be used, it is still not clearly quantified or defined. And hopefully, the upcoming so-called European Health Data Space, the EHDS, will provide a more clear regulation on this. And then the next project is about the big picture. Different from federated EGI and GDI, where the main focus is about genomic data and a phenotypic data. The focus of this big picture is about digital pathology slides, which I show at the bottom. And the idea is to create a central repository of digital pathology slides to boost the development of artificial intelligence so that it will try to provide some petabytes of data with 3 million whole slides images, including metadata. This will be the basis for training of powerful artificial intelligence tools. And there are 15 countries with 45 partners being involved, and the project will last for 6 years with a total budget of 70 million euros. So what kind of role has NBIS been evolved? As the underlying system, which means that the central repository. The system is developed and maintained by NBIS in collaboration with LXC Finnish node, based on the similar technology used to federate the EGI. This is where NBIS will contribute to. Right. So at last, I would like to briefly introduce the collaboration between NBIS and EGI. And I believe this is one of the reasons I been invited here to give the talk. So our collaboration actually already started in January of 2015. So many years has passed. And this collaboration has been strengthened since the end of 2022, when NBIS became an associated participant of EGI. So what do we do? NBIS develop and maintain web services using EGI cloud resources. For example, TopConst, which I mentioned, which is a widely used membrane protein structure prediction server, and also like NBIS RShiny server. And in return, what EGI do? EGI, they provide with a generous compute cloud resources, which are distributed mainly in 3 nodes, from Rex Bali from Italy, IN2P3 from France, and TRFC1 from Turkey. And it provides in total about 216 CPU cores and 768 gigabytes of RAM. And I can promise that all this effort and resources are not wasted. So here I show some KPIs. And yeah, currently we have like 7 NBIS service utilize EGI resources. And these resources have been used by a large number of users, as shown in the figure to the right. Since 2020, every year there are more than 700 users, yearly active users. And these services has been associated with 9 publications, resulted in more than 1,700 citations. And now I'm going to summarize my talk. NBIS is a distributed national infrastructure in Sweden, as I mentioned. And we provide bioinformatics support with expert knowledge and innovative data integration to make bioinformatics easily accessible for life science researchers. This is because like many research groups in Sweden, or probably also other countries, they are doing life science research, but they probably do not have a specific bioinformatician in the group. And we will centralize all all the resources and then provide it to these smaller research groups. And we also provide services, software development, efficient data publication for open science, and access to high performance data analysis methods. And in addition, we provide advanced training that will boost the application of bioinformatics. And moreover, NBIS forms the Swedish node in LXC, and we participate in relevant international projects. And finally, I want to highlight that NBIS has a long-standing collaboration with EGI, and which has yielded some fruitful results. So, thank you very much.
Thank you very much for this very informative, overarching talk. Time for a few questions.
I have one. So first, thanks for being here. I'm Tiziana Ferrari, GI Foundation. My question is, how do you foresee the NBIS computing requirements evolve in the coming years? So will the demand of computing, storage, or advanced services change, increase? How do you see the future?
Yes. So for some of the projects I mentioned about, like, for example, the GDI and the federated EGI, or the big pictures, and they actually do require tremendous amount of storage. And they are not a requirement for the computational resource. It's about the storage. Like for the federated EGI, we are anticipating about 400 terabytes of data being coming, and for the big picture as well, like 400, even more, because there are like 3 million slides need to be stored. Yes, it'll be great, like, but one of the problems is that these are sensitive data, which means that they should be stored nationally. that EGI would provide is, of course, really good, but there's it's about skeptical from the lawyers that whether or not this data can be stored outside of Sweden. That's a problem. So we do have a need, and currently we are utilizing, for example, for the federated EGI, we are using a national cloud provider called SafeSpring to store this. And then for the big pictures, it's the Ada Data Hub, which they actually do have some fundings for hardware, and it's applying for that. Thank you.
More questions?
Thank you very much. So you've spoken about images, and the problem with images is that you need to know something about the device which generates the images if you want to make severe answers, severe questions. So this quality control, in particular, if images are coming from different modalities, how do you ensure this quality if you archive the image and need these images for training AI systems?
Right. So for these pathology digital images, and they provide with metadata. And in principle, especially like they also provide, if they are in the DICOM format, you can do this kind of quality control. But I have to agree that for the big picture project, so far, we still haven't introduced this kind of quality control yet, because we are at the stage, try to attract as more images as possible. So we still cannot provide put too strict requirement to the data provider. But this is already in consideration, and especially in the UCAN project, the European Cancer Imaging, for example, they have been actively talking about the format of the data and the quality control.
I have one question. At half point, roughly, you mentioned that in Sweden, there is the national computer infrastructure, which was recently renamed, and there is a kind of, I don't know, credit-based access distribution. I'm curious how that works across communities. Who decides whether bioinformatics or physics or earth sciences gets the credits or compute time on the system?
That's a good question. So the model it works in Sweden that they will send out so-called the course. There are different levels of course, a large course, medium course, and small course. And for the large course, it is only the PI of the research group can apply. So it's almost function like applying for a research grant. But instead of applying for money, you apply for the computer resource. And then for the moderate or for the small scale, which even at the PhD level, you can apply for small amount of computing resource for you to use. So it's not specifically defined for the field, but it's by case for the applications.
But is this application decoupled from the science grant application, or I can incorporate the request for compute when I submit my research proposal for the national R&D grant?
Sometimes you actually need to provide a plan for applying for computer resource in the grant application, but it's not considered within the grant application.
Thank you. Thank you very much again for the speaker.
Thank you.
Let's move to the next presentation. So I warmly welcome Nadia Pinardi, who is here to present us the Coast Predict initiative, one of the programs that served under the UN Decade of Ocean Science for Sustainable Development. Nadia earned PhD in applied physics from the Harvard University and is currently a full professor of oceanography at the University of Bologna. Her research interests are diverse, covering ocean numerical modeling, predictions, data assimilation, numerical modeling of marine physical biological interactions, and the dynamics of pollutants in marine environments. Among her notable achievements is the conceptualization and successful implementation of ocean forecasting systems that are used across various global regions. I'm very pleased to have Nadia here, and I hope that your presentation will boost the collaboration between EGI around this new initiative.
I'm here for that. Thank you. Yes. Thank you. Yeah. Good morning, everybody. So thank you for reserving a bit of time to look at the ocean. which is our life in the planet. And this is an attempt to leap forward into the future while establishing an international network on the coastal issue. Let's see, yeah. So I will try to show the major facts about the climate change and ocean, how the two are related, and then show you how the UN decade from 2021-2030 is trying to address major societal challenges. And then what we organized, and we hope to work together with EGI in the future. We need to have the federated issues that were so nicely exposed before me, to advance into the global sector of coastal management, risk management, and then some conclusions and outlook. So just to remind you what is that oceanography is at the core of climate impacts. Everybody knows about sea level rise. And this is ocean dynamics coupled to the structure of the coastlines that gives major hazards, as you have seen recently, the Hurricane Helene and the storm surge. The other major issue is that oceanography now can give these maps of hazards that are at the core of risk science for the global ocean. Here you see this fantastic projection in 2100 of the frequency of a 100-year storm surge event that will become frequent as little as every 10 years, and if not 1 year. So extreme events are a very important topic for us to try to solve worldwide. So the decade started in 2021. It will last until 2030, and we have to leave a legacy. We have to leave a legacy for science to be impactful for these kind of events, for these kind of urgent matters. The part that I'm mostly dedicated on, and CoastPredict is devoting its attention, is the increasing of community resilience to ocean hazards. And we hope to arrive at the outcome, or at least set the basis for a safe ocean in the future years. So let me tell you what now CoastPredict has envisaged as its major goals, and how we try to proceed, and how we are building toward a GlobalCoast Cloud system that will serve the aim of increasing community resilience to coastal hazards. So CoastPredict is one of the 40 decade programs dedicated to unravel major questions in ocean science. And in our case, we are focusing on, we're part of the Global Ocean Observing System, and we are focusing on integrating real data observations, we call in our field, and predictions, and make a system that will instruct in the future more advanced systems such as machine learning, forecasting, and analysis. And in practice, all this to identify solutions for managing risk in the short term and planning mitigation for the long term. So one of the gaps is to make accessible the digital ocean. Now you see here what is available, but how is available is not accessible, is not very usable. We would like to arrive at the end of a path that starts now and will go in the future, where a user can access. So you see, all the models now arrive where the people live. So we have information for managing risk where the people live along the coastal lines. And we have an accessibility and usability issue. Another gap, we need to expand the digital twin for nature-based solutions. We know we cannot go with only gray solutions for coastal protection. So this is a typical question that now we have to spread worldwide. Seagrass meadows are capable of attenuating waves. We did it for Italy. And we could answer the question, what is the landscape of my seagrass that is most effective to get wave reduction, wave energy reduction? But we want to spread this to help to construct green infrastructure for coastal protection. The other gap is a complicated one, is the recasting of the problem in terms of multi-hazard risk. So you have seen here a little bit of vegetation. You have seen here the physics, the ocean moving, and we have much more than that. We have tsunamis, which have a different risk. We have marine heat waves. We have algal blooms, and putting this together in a full multi-hazard framework of evaluation and management for reduction is complicated. But we are trying now to, along the way that we are accessing more information, recast the problem at all stages and without forgetting the governance changes, which we had already an example for the health sector, but it's the same for us. There are no real legal terms to exchange data, even though pollution from one town that goes to the ocean arrives to the other nation. What do we do about that? We don't know the source of pollution because it's sensitive data. Okay, so we have the same problem across the disciplines. Now the voice is not going. I wanted to give you the impression with the coworker that develops software for us, but we cannot hear it. It's gone. Okay, so the solution is to expand the cloud-based computing and infrastructure to enhance accessibility. We have reasoned with a large group of people. They all agree we want to do that. So global coast, this is our experiment to demonstrate cost predict solutions. We have collected users and scientists at pilot sites with integrated observing to demonstrate how to implement integrated observing and predicting systems. We have, we would like to, and we are starting to design an innovative cloud computing infrastructure for global coast. And we want to create as much as possible globally replicable solutions and services, public-private. We believe public cannot do everything. We need to get some serious thinking on how to work together with the private. So the Global Coast Survey was running last year from July to October 2023. And the numbers are that we have 130 pilot sites, almost everywhere around the globe, and 270 institutions in 64 countries working with us. This is the plot. We call it the Global Coast Network. We are making the network. We are having a memorandum of understanding for working together. And we would like to build the cloud systems that will make accessible the data, and both created locally and coming from other sources, external sources. But we focus on impact areas from the beginning. We said, what are our user cases? So first of all regions had the majority of people thinking they have to implement on the cloud early warning systems of different kind for different risks and for different hazards. They want to know a lot about climate change on the coast. And I'll remind you that IPCC AR6, the 6 assessment reports, arrives at scales that don't see the coast. The coast is out of it. Okay, how to do downscaling, that's a science issue, but it should be immediately thought to go on a cloud, and so on. And then we have the others. But also, we said, if we develop the science and the cloud and the accessibility, what are your users for these 130 global coasts? We have them, they're connected. We have local regional authorities, management agencies, marine protected area, national weather and ocean forecast centers, the research community, national agencies managing directives and frameworks, aquaculture, mariculture, etc. Okay, so here is the initial design. We think of having a global coast where all new information created by Coast Predict will exist, and that will be interfaced appropriately with existing databases, bringing to the local region an accessible information and a usable information. Now, you have seen probably that we have a large part of users and colleagues that work in the Global South. So we believe that this is a way to overcome the technical barriers that do not allow these people to access as frequently as the other countries. We want to have this cloud system, which is more a federation of cloud systems, to connect globally and enable public-private collaboration based on the data on the cloud. And clearly we have to look at the problem that we're talked about before on the accessibility of some data. But I have the idea EGI has some solutions for that. Okay, so in this cloud, we will have the 3 pillars of the ocean value chain: the real-time observing, the routine multi-scale predicting, which will routinely assimilate this data and give a forecast into the future, and the customized application, the digital twins. So just as an example, we have prototypes, clearly. We couldn't do this without having already prototypes. Here is a prototype for, yes. So this is a prototype for US East Coast. This is Georgia coast, with an innovative model that goes into the rivers. So we have a river ocean continuum that is modeled, no boundaries, no artificial boundaries, an early warning system for hurricanes coming and storm surge. We have proven that it's possible to downscale to the coast climate scenarios. It's a procedure. We are developing a standard now. How do you go from the global scale to the coastal area? We have oil spill pollution applications with hazard index defined. So we found a general principle by which you classify different coastlines with different risk. if there is an oil release in any of these dots, and then the nature-based solutions prototype that I've shown you before. Okay, so what do? How do we get to the ocean we want? The motto of the decade is the science we need for the ocean we want. Is a bit aggressive, so I just said, how do we get the ocean we want? This is my recipe, which was shared by Professor Siders. Do more and eat veggies. Choose to adapt. Don't wait for mitigate everything. Be creative and use a cloud. And that's it. Thank you for your attention.
Thank you very much. Time for questions. Marta.
I think you were interested in a presentation. So do your 130 pilots have comparable modeling so you can have comparable data?
Yeah, thank you for the question. That's very important. Clearly not. The Global South is missing a lot of computational resources to do the kind of modeling that we do in the Mediterranean, for example, in the North Sea or globally. So Coast Predict is going to implement new models, have a lot of training done. So yes, we do a lot of training on this. We also offer new solutions such as citizen science sensors, low cost, high efficiency one. So we have groups in Coast Predict that group of experts on citizen science sensors that will come and implement where is needed. And yeah, so we have also the issue of the quality control that we were talking about. And yes, I think that it is important to start to collect more data for the coast because we don't have data. And then evaluate the quality with the time, as it is done even for the health system. But I think it's even more important for us because we don't have a way to check our models, to validate our model and calibrate our models. And then thinking that in the future we will go toward more quality controlled data as long as we have them collected. Okay, thank you.
Other questions?
Nadia, thank you very much. Bjorn Beckerberg from Deltaris. I was thinking about digital twins and the requirements of numerical models in particular. Thinking about the definition of a digital twin in terms of being interactive so that we can run what-if scenarios. My question to you is, what do you think are the biggest challenges that the numerical modeling or the modeling community are facing in the future to serve this need?
Very good question. So the one I have shown, even though I call it because we don't do the loop. Okay. And doing the loop in the natural environment takes time because you have to see, you have to monitor, see how things are evolving and then get it back. And it takes years, right? So to speak, in many months, at least. Vegetation growing and this, yeah. Okay, so apart from that, now the challenging of the model. Yes, yeah, I think the best way to think about this, since it is a challenge, is to have a phased approach. So, and that means that we also give, we don't raise wrong expectations. So if somebody tells me, we were discussing with Annabella here, great expert of this, about morphological changes. And I say, I do a digital twin with vegetation and morphological changes on the coast. I think is a bit far away. Okay, so we have to find, the challenge is that we have to connect many different models that were never connected before. So XBeach together with a wave model, a wave watch, anything that is already available. How to couple this is an issue, and then have a phased approach. So that's what Cost Predict aims also of doing with thinking, and Deltares is certainly a very important player in this. Thank you.
Maria Girone from CERN. Many thanks for this inspiring talk. I have a question about resources, actually. So can you comment a bit on the kind of resources that you use now, and what are, in your opinion, the anticipated needs for this decade that is ahead of us for your science to become effective in a way?
Yeah, so we have done a lot of estimates of resources here and there. Now we are making it for the GlobalCoast Cloud. We have a workshop this afternoon to elucidate some of these initial thinking. Okay, so the first thing, and we sort of plan some phases. The first phase, we know it's a storage phase. So it is notebooks, so because we need to have, again, don't raise the expectations that are not, don't have the infrastructure to keep. Oh, I forgot to say, we now use HPC, period. We use HPC. We have HPC at CMCC dedicated to do this. We have Cineca. We have, many other, Barcelona. So we use HPC. Now is HPC. So what we want to do is first reach the accessibility, right? Advance into the accessibility limit. So we want first to show that all these HPC production is made accessible to people who don't access this. And simple notebook, we can actually use only CPU instead of GPU. Okay, so the second phase is instead that we want to have the local people have their production. That will be on the cloud, and that requires more computing capacity, something that is currently available. I'm just telling you this because numbers, I would say something wrong, I'm sure. We have so many numbers in our head that, so it is currently available. So what we will do in 2 or 3 years is already available now in terms of computational data production. When I talk about data production, is observation collection plus modeling, which is more intensive as data production, clearly. Then there is the next issue, and the next issue, however, is being prepared now, as was actually said, is connection of the cloud with the HPC. That's key, in my opinion. Has to be done well. We have to see a lot of convergence into this, and that's my hope.
Thank you very much again for the speaker and for the questions. Let's move on. Our third speaker, unfortunately, couldn't be with us physically, so we will hear the third presentation remote from Davide Salomoni. I hope, Davide, you can hear me introducing you. Davide is a long-time collaborator, contributor, partner of EGI in many different positions he held. Today, he will speak to us in his current role, which is Innovation Manager at the ESCS Foundation, the organization that's managing the Italian National Center for HPC, Big Data and Quantum Computing. In this role, he promotes partnerships and innovative solutions that are developed across the 50 partners of this organization, including academic, research, and business organizations. He also coordinates the ICSC Resource Allocation Committee that's responsible for the service request and resource allocation for international and external participants. And on top of that, he's member of scientific advisory boards at the German Holzheim Federated IT Service Group, HIFIS, and also for the Portuguese National Distributed Compute Infrastructure. Prior to this role, he was working at the INFN as technical director, and in that role, he contributed to different middleware solutions. Many of them are still in use today. So I welcome Davide and looking forward to your presentation on this new Italian initiative.
Thank you. Thank you very much, Gabriele. I hope you can hear me okay.
Yes, we can hear you perfectly, and we see your slides on the big screen.
Okay, thanks a lot. So apologies for not being able to be there, but I had some personal issues. I couldn't come to Lecce. So I'll deliver my presentation from remote. As Gabriele said, thanks for the introduction. I also would like to thank the organizer for inviting me to give this talk. I will briefly talk about this new initiative called ICSC, which is the National Research Center in HPC, Big Data and Quantum Computing. So basically, very quickly, because many of you perhaps have already heard this information, with the National Recovery and Resilience Funds, the Ministry of Education and Research funded 5 national centers. One of these is ICSC, which is dedicated to digital, so HPC, Big Data and Quantum, and this is what I'm talking about. The duration was initially 36 months. It's been very recently extended for a further 6 months, so it will end in February 2026. Each of these centers is funded with about 320 million euros. So the kickoff we had in actually November 2022 in Bologna. Here you see a slide from the kickoff, which was just the day prior to the inauguration of the Leonardo Supercomputer Center, and that's not by accident, as I will come to this in a second. So, but let me say what are the main objectives of this initiative. So there are 2 main objectives. The first one is to create a national computing infrastructure, first of all, boosting the existing big infrastructures, HPC, HCC, big data, and federating them together with the network, of course, plus adding to this new resources procured with the NRRP funds. On top of that, we want to provide a flexible and uniform cloud interface to all of this. So I think this will neatly connect to Nadia's talk that just ended. The second objective is to create an ecosystem around this infrastructure. So that's not only the hardware itself, but also to have the competence, the know-how, and this will foster the exploitation of the computing resources. And we'll see how in this talk. Now, something that I would like to mention is that it's remarkable that the Ministry of Education and Research asked us to direct all our activities under a single motto, which is go from research to business. So keep in mind also the impact on society, on business, on the country in general. So not only purely research activities. And this is the consortium, if you want, about 50 partners distributed across the country. As you can see, they are composed of research institution, university, as well as big enterprises. You can see also the budget here. I'll come to the budget in a few slides, so I will not discuss this here. So the organization is that we have a central hub, which is the foundation where, for which I am working now. And then we have, initially we had 11 so-called spokes, we start counting from zero. So spoke zero for us is the building up and the boosting of the infrastructure itself, what we have called the supercomputing cloud infrastructure. You can already see from the name, it puts together both the cloud part and the HPC part. Plus we have 10 so-called thematic spokes, 2 of which are technological spokes, spoke 1 and 10. And very recently, we added a 12th spoke, which is actually spoke number 11, which is a transversal research group on societal implication and impact, which is very important for the future of the center, of course. So going back to the budget, as I said, the 320 million euros, roughly half the budget is spent for the infrastructure, and the rest is divided across several measures. On the left, you see the numbers of new recruitments we were able to do so far. It's about 600 people among new researchers, PhD, postdocs, and so on. And on the bottom, you also see that there is an annual contribution of about 6 million euros coming from the ICSC members to participate to the project. So going back to the innovation part, so we have divided the innovation themes in 4 main areas, so all under the word and the verb act. So act on infrastructures, so that is the hardware part. Act on needs, so the requirements of our stakeholders. Act on know-how, so the expertise, how do we build up the expertise. And finally, think about the future, act on opportunities. And this has to be done within, of course, the national context as well as the European context. So all I'm going to present from now on will link to these 4 themes that I have mentioned. But the overall plan, basically, of ICSC is connected to its foundational elements. First of all, we have a publicly funded infrastructure based on open science and fair data, which means we have no vendor lock-in, so we're not tied to a commercial cloud provider, for example. It is for research and business together. As you have already seen, we have a massive ecosystem. We will enlarge in the coming years, that transparently integrates the various technologies, cloud, quantum, and HPC resources. I will come to this through a continuum of solutions, the supercomputing cloud infrastructure I mentioned before, with a dynamic solution portfolio, which must be production level, so not only test beds. And finally, last but not least, we also want to be able to federate other resource providers and to aggregate diverse communities and organizations. Now, let me say that nothing like this, as far as I know, exists at this scale in other countries. And because of this, this goes well beyond the 2022-2025 National Recovery and Resilience Program. We believe, and the ministry shares this view with us, that this is a national strategic asset for innovation for the country. So let me start with infrastructure. There are, of course, a couple of big Italian data centers which are situated in the map that I showed earlier. One is from the National Institute for Nuclear Physics, INFN, was inaugurated in May this year, and the other one, of course, is Leonardo, which was inaugurated in 2022, and in probably beginning of next year, we'll have also an expansion to this Leonardo. The tender is already out. So, but to complement what I said about the continuum of resources, we have introduced also this concept of HPC bubbles. So the ambition is to deliver HPC at all scales. You can see in the picture the different scales of computational possibilities. You start on the laptop, on the user desktop, and then you end up at Leonardo, which is one of the most powerful supercomputers in the world. But in between, you may also have HPC Praise Italy, which is a so-called tier 1 HPC system. But even before that, we have introduced these clusters, which will be distributed across the countries in multiple places with a non-negligible computational power, because if you sum up all the clusters we have already purchased, you come to about 14 petaflops, which is enough to enter the top 100 anyway, aggregating all of them. And this includes both many cores and GPUs as well as FPGA system. So the idea is to provide not only just a single very big supercomputing center, but rather a continuum of solutions where, depending on the use case, you can use the bubbles for R&D and then move to Leonardo, or as we hope, we think it will be more likely in some cases, you just do all your computation distributedly on the bubbles. Now, the question is which resources are provided by the national centers? Of course, there are the regular bare metal resources, the cloud, traditional HPC, the quantum computers, and then there are the standard services built upon these resources, and you can see examples of these in this slide. I will not describe, these are well known. We expect to open soon, however, some consultancy services to customize the ICSC solution portfolio. And in the next slides, probably you will see why this is highly needed for us. Now, the second question, having said what are the resources, who can access the resources and how? So at the moment, the request for resources and services can be made by all the ICSC partners, of course, the 50 partners, both public and private. We have issued cascading calls. I have a slide about them. So beneficiaries of these cascading calls can access these resources. We have a startup program. Again, I'll describe this briefly. Or if there are projects for which there is an agreement with sharing of resources with ICSC, of course, they can also access the ICSC resources. And as Gergely said at the beginning, the allocation of these resources is done via a committee called the ICSC RAC, the Resource Allocation Committee. And you can see some stats here in the slides about the requests that we have satisfied so far using both Leonardo, INFN cloud resources, and so on. So let me go to the support for innovation. We have identified mostly three main areas. One is what we call the cascade grants. We have allocated 10% of the budget, so 32 million euros for cascade grants, roughly 10% of the budget for what we call innovation funds, and then a new initiative which is called ICSC for Startup. So for the cascading grants, these are calls which are issued by the thematic spokes of the national centers. Remember, these are the vertical spokes aimed at institutions that are not already part of the ICSC consortium for the implementation of activities, projects that are linked to what is done in each spoke. We have published and already closed 13 of these calls with a total cost, as I said, about 32 million euros. In the URL there, you can see the details of each of these 13 calls. For what regards the innovation projects, these are reserved to ICSC affiliates, so the members of the ICSC consortium. And we have approved 76 projects. Now, the novelty of this is that these projects must be led by a commercial company, and they may also involve other both commercial companies or public companies. Now, on the right here, you see a graph which shows the connections that have been established between public and private partnerships. In red, you see the private affiliates. In blue, you see the public ones. So it's quite notable that through these 76 projects, we were able to establish a number of connections. This is something that, at least for Italy, is totally a novelty. Nothing like this was done before in terms of public and private partnerships. And what are these innovation projects about? Very briefly, there touch areas of industrial interest on several topics, and you can see some of the usual suspects here: predictive maintenance, weather and energy, fuel efficiency, digital twins in various incarnations, for example, precision agriculture, but also digital twins for cities, hazard mapping, and so on and so forth. And at the URL, you can see a database with the public information about the innovation projects. The third leg of our innovation activities is a support to startups. which is a very recent initiative. We launched it just before summer 2024. So we aim at targeting innovative startups and SMEs. We have an initial seed funding of 500K. Notable is that this is not given through recovery funds money. So this is the center money, if you want, so which relieves us from some bureaucratic things that otherwise we had to follow. And the requirement is that we expect the proposal of a highly innovative project from startups or SMEs related to HPC big data, and have 3 participation options. So you can require some limited financial support. You see, we only have 500K in total, so that's not too much. We don't want to be a venture capitalist in this. We just want to support the accomplishment of a certain project. Most importantly, we want to access, we allow to require support for accessing ICSC computer storage resources, or you can ask for support related to the implementation. So for example, I need to write a machine learning model. So I'm looking for expertise. So we go at our affiliates and then ask for contribution there. And we're just examining the first about 15 applications we have received, and the goal is to sign the implementation of these first by the end of this year. In addition, we have been expanding agreements with the external world, if you want. So for example, here you see a number of initiatives we have set up with enterprises. Some are in Italy as support for startups, but others, for example, in Switzerland, in the Basel area, where the big pharmaceutical companies are, with an important project funded, I think, by the Ministry of Industry in Germany, again related to innovative projects. And the third one is actually also a novelty. It's a call issued by EuroHPC for provisioning an industrial-grade supercomputer, so a supercomputer dedicated to enterprises, which will be installed by one of the EuroHPC hosting entities. So in our case, Cineca is part of ICSC, so it will be installed at Cineca, and we have been granted this, so the tenders will go out soon. So this is dedicated specifically for industrial use. Another initiative we have started is what we call the ICSC Observatory. So this is an observatory on trends and application of all things supercomputing. We had a kickoff meeting at the beginning of this year, and we have a number of planned events of this observatories. 3 of them have already taken place, but as you can see, there are a number of other events, plus some webinars that will take place between now and July next year. So there is a very tight schedule for this. We have an ethics and data governance board. This is very important for us. We have put in process an ethical review of all the projects that go through ICSC. This is now part of the overall activity process. We are defining a global data management plan, which is rather complicated, as you can imagine, since we have so many partners and therefore so many data sets and access policies. The implementation of guidelines is defined together with our international, actually, ethics governance board. And last but not least, we have been actually submitting proposals. I cannot disclose more, but about European projects related to ethics, again, together with ethics governance board members. For what regard the Open Science Cloud, European Open Science Cloud, I need not tell you what it is. Let me just mention that ICSC has applied to become a national node for Italy of the European European Open Science Cloud Network. And as we have discussed this with other Italian institutions, ICDI, for example, Italian institutions that are not already part of the ICSC consortium, welcome to join the national node. Let me quickly move toward the end, but first of all, let me mention the European context. And for us, the European context, as mentioned many times by the European Commission, revolves around AI. So there is an important call which is out now, which is called Euro HPC AI Factory. It is due very soon, so this is basically where we are spending most of the time right now. And the aim is to fund some supercomputers which are AI oriented with the 200 million euros by Euro HPC, coupled with 200 million euros by the national funds. You can find the details if you're interested here. So I'm not going to describe the details. I'm just going to show you this slide, because this slide captures the overall scenario of AI factories together tightly with the AI ecosystem that the European Commission expects. So on the one hand, you have a national strategy on AI factories. You can see it on the right side of the slide. And if you look at the bullets here, this is a slide coming from the EC. You will find, I have briefly sketched them, that they are basically covered by the ICSC initiative, but this has to map with the EU strategy on AI factories. So this is the part that we're trying to work on right now, so to combine the national strategy with that together with the EU strategy, and to have a successful application for an AI factory in Italy. So some final words about innovation and impact, which is actually part of my daily work. On the right, you see probably a familiar slide coming from the European Commission. Let me just say that the impact of the activities can be seen in multiple domains. So, for example, scientific, economic, and social. And it's our task now to translate all the activities that we have been doing in these roughly 2 years of existence into these kind of impacts. But a thing that is very close to my heart is that if you look at the plot on the right, sorry, this is in Italian, but this is the 10 most profitable, actually, with the higher capitalization enterprises in the world. And if you look at them, you will recognize immediately that most of them, the vast majority of them, have to do with knowledge, not so much with goods. So we're rapidly moving from an economy based on the production of material goods to an economy based on knowledge. So if I wanted to synthesize what an HPC system is, or in ICSC lingo, a supercomputing cloud infrastructure is, I would say that it is simply a knowledge accelerator. So this is what we are looking at in our impact view. So if it is a knowledge accelerator and we want to move from goods to knowledge, this is closely linked for us to the creation of a portfolio of educational services, which is what we are actively working on. So we now have an education area with some main lines. So the first main line, of course, is to bridge the gap so between the strong vertical skills, scientific domains, and the IT skills, which is, let's say, the lower layers of the OSI stack, if you want, in HPC, big data, quantum, and cloud domains. And to this extent, we have already launched the first education initiatives in several disciplinary areas. So, for example, we recently launched an initiative in bioinformatics. So the idea is to train new professionals, not replacing university, of course, but giving some education modules, as well as to define one or more job profiles, which eventually probably will be, this is our aim, certified in some way for some supercomputing data management professionals. So let me finish with some significant events that took place recently. In May this year, we had the inauguration of a supercomputing quantum computing center at the University of Naples. This is the first quantum computers based on superconducting technologies, which actually was built in Italy, and this is being expanded right now with additional qubits to increase the power. So this is the first instance of a quantum computer for ICSC. 2 more will be provisioned hopefully by end of this year, beginning next year, and installed in Bologna. Also in May, we had inaugurated the last part of the Bologna Technopole with the INFN Tier 1, which actually is a milestone for us because it complements Leonardo, which was already inaugurated in 2022. So now we have both the HTC, the high supercomputing, and the high performance computing part together with the distributed cloud infrastructure that I mentioned above, all in place. And finally, this is a dissemination event, but is also very important. This is Piazza Maggiore in Bologna in June. We had some reservation about having such an event in a big place like that in summer, but as you can see, this was like a research and conference show on Science 4.0, demonstrating also the use of quantum technologies, and as you can see, it actively participated. So thank you very much for your attention. Again, apologies for not being there. With any questions, I'm available here online. Thank you very much.
Thank you, Davide. I hope you heard the applause. I open the floor for questions. Please don't leave the room because there will be a group photo after the questions, okay?
Hello, my name is Erik Huizer. I'm from GEANT. On one of your first slides, you said that the Ministry of Education and Research is now directing all business and research to this initiative. I assume they would have to use the GAR network to reach you. And GAR is one of our members, and they always assure me that no business traffic is allowed on their network. So how does that work?
Yeah, thank you, Eric. Thank you very much for the question. Yes, we are using the GAR network. I briefly mentioned this. Actually, through the NRRP funding, the GAR network is being expanded to cover actually multiple terabit links in the backbone. This is not a production, this is not for enterprises to do their core business, is to create a research to business environment. So it's industrial research, if you want. So there is no production activities going on in the network right now. But it will not be, and not with GAR. So this is for sure.
Further questions? Yes, Tiziana.
Thanks, Davide. Tiziana, EGI Foundation. My question is how this novel Italian initiative can help EGI Federation to support international scientific collaborations like the one presented by Nadia earlier on, which are international and include Italy, but are broader in terms of scope and reach. Thank you.
Thank you, Tiziana. Yes, as you mentioned, Nadia presented a case where there is an international collaboration. CMCC, by the way, is part of ICSC as well as Cineca. For what regards the Italian part, Nadia, I think we have you covered. However, for the international part, I think that we should probably discuss on how to connect these resources, also given the fact that Nadia mentioned multiple times the need to go with cloud solutions. We're actually also, I didn't discuss this, we're actually also working on a lot on the edge part, which means collection of data from remote sites. We have multiple projects that are actually collecting data remotely and then transmitting it to cloud or eventually to HPC nodes. So what I see is that we should probably exchange views on opportunities. As I said, the opportunity, act on opportunities is one of our pillars for innovation, with EGI to connect what you see, what we see, and work together.
Thank you. Yeah, there is a third question, and that will be the last.
Hi, my name is Tina. I'm from Inframer. So because my question is, like, often when we use HPC and when we want to use the data in the cloud, like ARCO format, analysis ready cloud optimized format, the problem is HPC compute node doesn't have access to internet. And what do you think about in your computing center, that do you allow the HPC user to access the data available on cloud, for example, using the high speed network like Xeon, you know, like the data in S3 on EOSC?
Yeah, so thank you. This is a complicated question. With big UHPC center, this is often the case, not always. So we know, of course, that there are HPC centers which are quite close in terms of network connectivity. However, there are solutions. One solution, as I mentioned, is to make use of the distributed HPC concept through the HPC bubbles that I have mentioned. By the way, these are being installed right now. So we hope that by fourth quarter of this year, so end of this year, beginning of next year, we'll have them in production. And these are typically more open than the traditional HPC centers. Plus, we have already demonstrated the connection between traditional HTC, high throughput computing resources and, for example, Leonardo at Cineca, right? So this, in a way, overcomes the limitation of, let's say, outbound or inbound network connectivity, but this has to be evaluated on a case-by-case basis. I would say that technical solutions are there. We are trying to play our part in making it possible to not only go through only the main HPC centers, which rightly so have in many cases tight access policies, but also there is the possibility to connect to them in multiple ways. Of course, there are some policies to be worked on, and I assume this will have to be evaluated on a case-by-case basis.
Thank you very much, Davide. Thanks very much again for your talk, for the audience, for the questions. So we disconnect you from Zoom. Thanks a lot for being here, even if remote.
Bye-bye.
And we have the group photo now, as I heard on the stage. So I guess my colleagues will guide the crowd to the right position. So. Yeah, so everybody should go on the stage, right? Yeah, so try to be on the stage.